All right, guys, welcome to Module 4, Lesson 2. So yesterday we sort of talked about what area is, and that is a measurement of two-dimensional space, or how much flat space something takes up. So you could think, for example, we talked about yesterday, like in real life, if you're measuring how much flooring or tiling you needed to put down in a room, you could measure how much area you had in that room, how much area you had to cover. And that's what we did yesterday, is we covered things. We worked on using different shaped tiles to cover different areas, different flat spaces on paper, different drawings on paper. And we saw how much space those drawings took up on that paper. And so we were measuring area by doing that. And so we're going to continue that work today. We're going to work with squares today, because primarily when you measure area, you measure like in squares. So you'll hear me talk about square units, square inches, square centimeters, sometimes square feet or square meters. But we always measure in squares, because that's really the way that's the easiest way to do it. It's the way it's done. And let's take a look today at a few ways of how we could do that. So I have my camera here again, and I'm going to do some actual drawing. I found that for this lesson, it was easier to do it this way than share my typical whiteboard with you. So took a crayon from one of the kids, and here we go. We'll do our best with it. So you'll see that we have a 12 square unit drawing here. All right, so I have, the reason I know it's 12 square units because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 3, it's like an array, 3 times 4. 3 times 4 is 12. So 12 square units. And something you might be asked to do today is develop another rectangle that has 12 square units. Actually, for sure, that's something you're going to do. And so you might say, all right, well, what other arrays make 12? Well, 2 and 6. So I could make let's move this over. I could make a 2 by 6. Again, excuse my my inability to draw perfectly here. 1, 2, 3, 4, 5. 2, 3, 4, 5, and then right down the middle. So again, Mr. Brunel's drawing's not fantastic, but pretend like it was, and pretend like there were 6 squares in each row. So we'd have, again, 12 square units. This square units part, super important, right? Square units, when you're saying, like, if you just said that the area of this is 12, that's incorrect. It's 12 what? It's 12 squares, right? That's the measurement we're using. Just like when we measured in milliliters or liters or grams or milligrams or any of those things, it was important to have a unit and an accurate unit. The same thing is true now. And this time, we're not just measuring a length. Like, you can't, say these were centimeter tiles. We couldn't just say that's 12 centimeters. 12 centimeters is a length that goes in one dimension from one point to another point, and that's it. Like, it goes from, if I was measuring one dimension, it goes from there to there, right? I could say that's 12 centimeters. That's not 12 centimeters, but you get the point. When you start all of a sudden make it a square, then you need to, and you're measuring area, you need to indicate that by saying it's square units, or square inches, or square centimeters, or square meters, or whatever you're measuring in. I could do another example here. I've done 12 two different ways, but how about this one? This is really going to test my drawing abilities here. 1, 2, 3. I'm going to be way off. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is also 12 square units. Right? I have 12 squares in there. This long skinny one, this 1 by 12 array, takes up the same amount of space on the page as these other two. all three of these cover the same amount of space. How do I know that? Because they have the same area, and area measures how much space something takes up. In this case, how much space something takes up on a page, right? And so that's the sort of work you're going to do today in our lesson. Is you're going to work with squares. You're going to compare different drawings, different grids, different arrays, basically, using squares, and you're going to compare the size of the area in those things. So you're going to compare square units, square units. Now, you're also going to be asked about square units, square inches and square centimeters. So say, for example, I drew, and we'll touch more on this in unit or lesson 3 as well, but say I did 4 square inches. This is a very much an approximation here. All right, so say I did 4 square inches. We know an inch is bigger than a centimeter, right? And then I also did 4 square centimeters. So say this is 4 square inches. I'm gonna move my camera a little bit so maybe you can see a little bit better. And this is 4 square centimeters. This is another lesson on why units are important. So 4 square inches and 4 square centimeters are not the same. We'll work on that class. Like you'll see, we'll actually give you inch and centimeter cubes and let you explore with them, but they're not the same. Just because they both have a 4 in them, that doesn't mean that they're the same. Like the unit, the square centimeter and square inch is really important because it helps determine what the actual area is. We need to look beyond just the number. So always check your units. That's sort of the purpose of me talking to you about this, is that say you get a problem set or exit ticket or homework or whatever, and 2 things are being measured and they both have 12 as a number. You need to make sure that you're still looking at the same unit, 12 square inches and 12 square inches. Those would be equal. Those would cover the same amount of 2-dimensional space. If you had 12 square inches and 12 square feet, the 12 square feet would be much larger than the 12 square inches. And so you need to pay particular attention to those units. And I'm going to continue to talk to you about units all year, but especially in this lesson because they're so important. And so you're going to hear a lot about square units, square inches, square centimeters, square feet, square meters, all that stuff. But I just want you to pay a special attention to it because it's super important. Let's take a quick look at your homework here on the screen, and then I'm going to send you off to work on it independently. All right, let's switch our screen share here. Whoops, wrong one. There we go. So this is your, I'm sorry, this is your problem set, not your homework. So today in class, again, you would have looked at student shape A and shape B and thought about, do they have the same area? And again, an important part, how do you know? So we're working on giving full explanation. So it's not enough to just say, yes, they do. Just like we've worked on all year, we need to be able to say why. In this case, they have the same area because they're both being measured with the same size square, and they have an equal number of squares. All right. And that same size square is really important, just like I talked about a minute ago with the centimeters and inches. You'll also be doing that, like that work that we started with, where find the area of this and then draw a different rectangle that has the same area. So you're going to see a lot of that similar work on your homework, as well as just identifying the areas of things, like being asked to say, like, what's the area of this? What's the area of this? When you do that, always include square in front of your unit. So square units, square inches, square centimeters, depending on what you're measuring in. All right, guys. Again, this is a language-heavy unit. So a lot of vocabulary, a lot of me talking and telling you what different words mean. And those words are really important. So I apologize in advance for talking a lot, explaining a lot about what units are, why they're important, what area is, why we measure it, why it's important. But this is really language intensive, meaning that we have to really make sure we understand the words that we're using because they really impact the math that we do in this unit. So, and they impact the accuracy of the math that we're doing. So, you're going to hear me explain a lot about units this time, this module, and you're going to explain a lot about I'll explain over and over what area is and what it measures. So um, you're going to hear me talk a lot. Sorry. All right, guys, keep up the good work.